What's up, geometry? Thanks for tuning in with another episode of Math with Mullins. Today we're looking at lesson 2.4, day 2, Algebraic Reasoning. Our main objective today is to be able to use properties of equality involving segment lengths and angle measures. The first properties we're going to talk about are these three. We have the reflexive property, the symmetric, and then the transitive property. And then all of these can be written in your notes. So you want to take time to pause the video and fill in this table. That's the beginning of your notes. But let's talk about each one. The reflexive property in real numbers form, you can say A is equal to, that's like if 7 is equal to 7, okay? If you have segment lengths, then that means AB is equal to AB, and the measure angle is measure of angle A is equal to the measure of angle A. Reflexive just means whatever you say first has to be incorporated next, okay? The symmetric property is just switching that around. If A is equal to B, then B is equal to A. Sometimes you may have seen this in the past, consider the commutative property, and that could be something that you could think about, but today we're going to be calling it the symmetric property. Then if you have a segment length, AB is equal to CD, then CD is equal to AB, and then if angle measurements, it'd be the measure of angle A is equal to the measure B, then the measure of angle B should be equal to the measure of angle A. The transitive property is like if this and this happen, then the first and the last thing can be brought together. So it's like connecting it with another hypothesis or another conclusion. If A is equal to B and B is equal to C, then A equals C. So see how we skip the entire middleman altogether? So same thing here. If AB is equal to CD and CD is equal to EF, then that means AB is equal to EF. And then for angle measures, if the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then the measure of angle A will be equal to the measure of angle C. Go ahead and take time now to pause the video here, and then once you have that table filled out in your notes, go ahead and click play, and we'll try something next. All right, here we go. You reflect the beam of a spotlight off of a mirror lying flat on a stage as shown. Determine whether the measure of angle DBA is equal to the measure of angle EBC. So we want to just look for, are these showing the equivalence? And if you look at the measure of angle DBA is angle 2 plus angle 3. And the measure of angle EBC is equal to the measure of 2 plus the measure of angle 1. And 1 and 3 are both equal, so that would mean it is equivalent, okay? So this is how we would explain it. The measure of angle 1 is equal to the measure of angle 3. Then that means we can take the measure of angle DBA, and that is what we said again, angle 3 plus angle 2. And we can substitute angle 3 with angle 1. So the measurement of DBA could also be found if we found the measurement of angle 1 plus the measure of angle 2, which in that case is EBC. So because of this, EBC is equal to the measurement of DBA, and we would be using the transitive property for that. All right, here we go. Name the property of equality that the statement illustrates. You take time to pause the video here, try these on your own, and then click play when you're ready to check it. This first one would be the symmetric property, because we're just doing the measure of angle 6 is equal to measure of angle 7, then the measure of angle 7 is equal to measure of angle 6. This next one is the reflexive, and then this last one is transitive. Okay, hopefully you did okay there. The next piece, it says a park, shoe store, a pizza shop, and a movie theater are all located in order on a city street. So that just means here's my city street. So what I did is I went ahead and just labeled them. Since they're all on the same street, that means they're all on the same line. And it says the distance between the park and the shoe store. So here's the park and the shoe store. maybe let's do this in a different color, is the same distance as the pizza shop and the movie theater. Okay, so I just made one tick mark is equal to the one tick mark over here. Show that the distance between the park and the pizza shop is the same distance between the shoe store and the movie theater. So what we want to do is we make sure that we show that tick mark. So we know, I'm going to maybe label these with a letter. P would be the park, S can be shoe store. Let's do pizza with the letter Z, and M is a movie theater. Okay, so we know that park to shoe store is the same thing as pizza shop to movie theater. So that would be the given. To figure out what the length is from the park to the pizza shop, we know that we can add park plus shoe store, park to shoe store plus the shoe store to the pizza shop. So that would be the segment addition postulate. Okay, so that means park to pizza shop could also be the pizza shop to movie theater plus shoe store to pizza shop. That would be substitution. So that the segment from shoe store to pizza shop plus pizza shop to movie store is equal to shoe store to movie theater. That would be another segment addition postulate. So now we can say that park to pizza shop is equal to shoe store to movie theater, and that would be using the transitive. Okay. There are other ways to prove this, so if you didn't prove it this same way, those are just one of the ways that I thought that you could prove it. Okay. Name the properties of equality that this statement illustrates. Again, let's take time now here to pause the video, try this on your own, and when you're ready, click play. So if JK is equal to KL and KL is equal to 16, then JK is equal to 16. This would be a part of the transitive because you took a conclusion from one thing and applied it to the hypothesis of another. This next one is symmetric. And ZY is equal to ZY, that would be reflexive. Okay, flipping our paper over tells us we are done. So that's going to be all for 2.4 day 2. Thanks so much for tuning in, and we'll catch you next time.